Hello students, welcome to online maths classroom. Today we are going to take up sequences and series part 10. This is the last part of this chapter, and in this part we will solve exercise 9.4 question number 1 to 6. This exercise 9.4 is available in the supplementary material at the last of your NCERT book. So let us start with it. First of all, we need to understand what is sum to infinity of a geometric progression. So let us derive the formula for sum to infinite terms of a GP. Let us derive the formula for sum to infinite terms of GP. And again we'll start with sum to n terms of GP. So you know that if A is the first term and R is common ratio, then n terms of GP are taken as A, AR, AR square, so on, so AR raised to power n minus 1. This is the nth term. Now let us take their sum. Sum is your A plus AR plus AR square plus so on, so up to AR raised to power n minus 1. The next step is you have to multiply both sides of this equation by R. Okay. So multiply by R, both sides. So it becomes R times Sn is equal to AR plus AR square plus AR cube plus so on, so. Okay. And here, because you are multiplying with R, here you will get AR raised to power n. So I need to write one previous term, so you can see as the same term is, okay, the previous term, say AR square, AR. So here AR n minus 1 will be the second last term of it. Okay. The next step is to do the subtraction. Okay. You have to do the subtraction. So I'll subtract 1 minus 2. So let us do the subtraction. What will I get? I'll get as Sn minus Rsn. So can I take Sn common, and it is Sn times 1 minus R, and here it is. Okay, here it is. When you will be subtracting, see the how subtraction will be done. This AR will be cancelled with this, as AR minus AR is 0. AR square with it. Okay, nothing is to be cancelled with this A, so it will be left as it is. AR cube with the next one, and similarly as you can see this AR square with the previous AR with the previous term of this number 2. So AR n minus 1 with this. So if you observe, I am left with just these two terms. So I get it as A minus AR raised to power n, which can be written as A times 1 minus R raised to power n. Okay. So Sn is your A times 1 minus R raised to power n upon 1 minus R. Okay. So this is the formula for sum to n terms of GP. And you know, this formula holds for R not equal to 1. R not equal to 1 means for R greater than 1 and R less than 1. Okay. For R not equal to 1. So we take Sn as A times Rn minus 1 upon R minus 1 when R is greater than 1. And Sn is A times 1 minus R raised to power n upon 1 minus R when R is less than 1. Okay. Now let us see what happens when your n is equal to 0. Okay. When n is equal to 0. Now when n is 0, what is the term R raised to power n will like? It will be R raised to power 0, which is your 1. Anything raised to power 0 is 1. So see what happens to this formula. Say 1 minus Rn upon 1 minus R. It will be your A times 1 minus R raised to power 0 upon 1 minus R as n is equal to 0. So it becomes your E times 1 minus 1 upon 1 minus R, which is equal to 0. So your Sn is 0 when n is 0. Okay. Now, number 4 cases, which is the sum to infinite terms of GP. That means when n approaches to infinity. Okay, a very big number. Now it will become r raised to power infinity. And this r raised to power infinity is approaching 0. Why? Because this is the case when r is greater than 0 and is less than 1. Means is a number which is lying between 0 and 1. So let us take, for example, r as half, as it is a number which is lying between 0 and 1. For example, let us take r as half. Now let us observe that what is happening to this term. Okay. See, as this formula Sn can be splitted as this formula 1 minus r. Can I write it as a upon 1 minus r minus a r raised to power n upon 1 minus r. Okay. So I am talking about r raised to power n or r raised to power infinity. We say it is turning out to be 0. Let us see why. R is a number between 0 and 1, that is we have taken it as half. So see, half raised to power 1, it will give me 0.5. Half raised to power 2, what will it be? 0.25. Okay. Now make it half raised to power 8. It is 1 upon 256. Now it will be like 0.0. Okay. Means this is becoming smaller as I am raising the power of this half. Okay. 1 by 2 raised to power 10 will be more smaller than it. Okay. It will be more smaller than it. Okay. So as I am increasing the powers of half, say I am raising them to infinity, what is happening? The number is becoming smaller as r is your fraction lying between 0 and 1, and that's why we can say that the result is approaching to 0. Means as n is leading towards infinity, this your number, this r raised to power n is approaching to 0. So if it is approaching to 0, that means this term will become 0. And as n is infinity, so I'll get the formula for s infinity as a upon 1 minus r. Okay, a upon 1 minus r. So this is my formula for sum to infinite terms of GP.
Let us take example. Find the sum to infinity of the series 32 plus 16 plus 8 plus 4 plus 2 plus so on so. Now you can see this is a GP which is endless, as a is 32 and r here is 1 by 2, and it is endless, so it is infinite GP. Moreover, we also conclude that r is half, which is less than 1, so s infinity exists, which can be calculated by placing the values in a upon 1 minus r, and the answer is 64. Second example is find the sum to infinity of series 32 minus 16 plus 8 minus 4 plus 2 minus so on so. So here a is 32, r is minus half, which is again less than 1. So s infinity exists and can be calculated by placing the values in this formula, and turns out to be 64 by 3. Find the sum to infinity of geometric progression minus 5 by 4, 5 by 16, minus 5 by 64, 5 by 256 and so on. So again, it's a GP which is infinite. First term is minus 5 by 4. Common ratio is minus 1 by 4. Again, r is less than 1. So s infinity, or s as we can write it as a upon 1 minus r, and after placing the values we get the value as minus 1. Again, let us see one more question. Express the recurring decimal as a rational number. Okay, the recurring decimal where 6 is recurring. Okay, the dot here means that 6 is recurring, means it is like 36 is there and 6 is recurring. So that means it is like your 0.363636 so on so up to infinity. Okay, so we can write it as 0.36 plus 0.0036 plus 0.000036 up to infinite terms. Okay, for simplification it can be written as 36 by 10 square, 36 by 10 is to power 4 and so on. So again, the first term is your 36 by 10 square. Common ratio is 1 by 10 square, which is less than 1. Okay. And by placing all the values in your a upon 1 minus r formula, we can get the solution as 4 by 11. Okay. So I think this is not going to create any sort of problem for you, and you can solve even the recurring decimal type of problem for finding out the infinite terms of GP sum. Let us start with exercise 9.4. Okay. Find the sum to infinity in each of the following geometric progression. Question number 1 is 1, 1 by 3, 1 by 9. Again, this GP is infinite, where a is 1, r is 1 by 3, okay, which is less than 1. So the formula of S infinity 1 upon 1 minus 1 by 3 can be applied by replacing the values of a and r in the formula of S infinity equal to a upon 1 minus r. And after calculation, we get the answer as 1.5. Number 2 is 6, 1.2, 0.24, so on so. So again, it's a GP with A6 and RS 0.2. Again, less than 1. So we can apply this formula 6 upon 1 minus 0.2, which is 6 by 0.8, which is 7.5. Number 3 is 5, 20 by 7, 80 by 49, so on so. Again, an infinite GP with A5, R, 4 by 3. Okay, 4 by 3. So S is equal to, or S infinity is equal to 5 upon 1 minus 4 by 7, which is 35 by 3. Question number 4 is minus 3 by 4, 3 by 16, minus 3 by 64. Again, an infinite GP with A minus 3 by 4 and R as minus 1 by 4. So again, less than 1, let's place all the values in the formula A upon 1 minus R. So it is after solution, it turns out to be minus 3 by 5. Number 5 is, it's a very good question. Prove that 3 raised to power half into 3 raised to power 1 by 4 into 3 raised to power 1 by 8, so on so, is equal to 3. Now you're familiar with, we have done some questions in your previous exercises of sequences and series, where you know how to execute this kind of product. Okay, when bases are same, powers are added. So it will be something like 3 raised to power half plus 1 by 4 plus 1 by 8 plus so on so. Now this power is framing a GP. Okay, and that is with A as half and R as half. So as it is infinite GP, we will apply the formula for A upon 1 minus R in the powers. So it is half upon 1 minus half, which turns out to be 1. So 3 raised to power 1 is equal to 3, which is the required right hand side. Question number 6. Let x is equal to 1 plus a square plus so on so. Y is equal to 1 plus b square plus so on so. Where mod a is less than 1, mod b is less than 1. You have to prove that 1 plus ab plus a square b square plus so on so equal to xy upon x plus y minus 1. Okay. Now observe this question first. You see that x is equal to sum of an infinite GP. Y is equal to sum of a different infinite GP, and using these, see the connection of a and b. Okay, you have to prove that 1 plus ab plus a square b square plus so on so, which is again an infinite GP. This is equal to x y upon x plus y minus 1. Okay, so that means all of these three GPs sum are related to each other. Okay, so let us see how to solve it. X is equal to 1 plus a square plus so on so. Let us apply the formula for S infinity, and we get the values as 1 upon 1 minus a. Okay, a is 1, r is a. Y is your 1 upon 1 minus b. This after applying the sum of infinite GP. And to the third one also, 1 plus ab plus a square b square plus so on so. Again applying this formula, I get 1 upon 1 minus ab. Okay, as common ratio is ab here. Okay, now let us come back to your right hand side, xy upon x plus y minus 1. Okay, now place the values of your x, 1 upon 1 minus a, y 1 upon 1 minus b, both in the numerator and denominator. Now let us solve it. By taking LCM in the denominator, we'll get this term. Okay, and after a upon b upon c upon d can be written as a upon b into d upon c. Okay, this will go up and this will be multiplied with this. Okay, so after solution we will get as 1 minus a will be cancelled with this, 1 minus b will be cancelled with this, and this will just fetch me as a is getting cancelled with a, b is getting cancelled with b, and 2 minus 1 is just 1, and minus ab. So I get it as 1 upon 1 minus ab. Okay, so that means from 1 and from equation number 2, I'll get it as 1 plus ab plus a square b square plus so on so is equal to xy upon x plus y minus 1. That's all regarding your sum to infinite GP NCERT solutions. I hope the topic is clear to you. Please practice it well. Thank you so much.